We are at the TensorFlow.org website, and scrolling to get started with TensorFlow, we will find the Tutorials button in the next screen. And we're beginners. We want to do the Beginner Quick Start. We will be running that in Google Colab, which is like Kaggle Notebook or Jupyter Notebook. It takes a moment to run. Here we begin. We will be installing the TensorFlow package. Notice we are importing TensorFlow as TF. From here on, TensorFlow will be referenced as TF. Click on that, and TensorFlow is now installed. Next, we will load the MNIST dataset of hand-drawn digits, hand-drawn numbers. We will assign that dataset to MNIST as a variable. The MNIST data will be loaded into 4 separate datasets. This is a good example of a high-level function in TensorFlow. We will be loading the xtrain, ytrain, xtest, and ytest separate dataset. Xtrain has all of the hand-drawn digits. Ytrain has the labels for those digits. Those 2 sets are used for training. Xtest and ytest has data from the test digits and the labels from those. Let's run that. And it has downloaded 11 million data points. Next, we build the model. The entire machine learning model is stored in the variable model. That is composed of these definitions of layers. The first layer of the neural network is our input shapes. 60,000 shapes of hand-drawn letters will be run through that. This will be a 28 by 28 set of input neurons. The second layer will be composed of 128 neurons. The third layer is a dropout layer, very interesting. Without that, we run the risk of overfitting the data, meaning it learns the training data so perfectly that anything outside of that, it will not understand. So by dropout, we actually disable some of the neurons in each run so that it is more resilient, more robust. Our final layer is composed of 10 neurons, 10 output neurons. Can you guess why? One output neuron will fire if it's identified as a 0. Another one will fire if it's identified as a 1, or number 2, number 5, number 9. One output neuron for each category. The final step in the definition of the model is the optimizer. This is the part that does reinforcement learning. So Adam is a very common optimizer. This is a common loss function. But the metric is interesting. Our metric is accuracy. In other words, the reinforcement learning system will run the model again and again, optimizing for accuracy. If we wanted to optimize for speed, our metric would be something like speed and not accuracy. Clicking the triangle, define the model that quickly. The fit command actually trains the model. That one little bit, model.fit, it's being trained with the xtraining data from hand-drawn digits and ytrain, which is the labels for them. It will do 5 epochs or 5 runs. In other words, the model will be trained and retrained 5 times. Once the model is trained, then we evaluate how effective is it. And there we use the xtest data from the 10,000 remaining hand-drawn digits, and the ytest data, the labels for those. Okay, this goes fast, so watch carefully. Here's epoch 1. We have it half trained. In 6 seconds, we have trained it to an accuracy of 91%. Epoch 2, 5 seconds. Our accuracy has increased to 95%. Third epoch, 5 seconds, increased to 96%. fourth to 97%. The last epoch, we've trained it to 97.65%, and that's with our 60,000 hand-drawn digits. And then the 10,000 test digits were identified with an accuracy of 97.55%. Notice that that's a little bit less than the training accuracy, which is what we expect. It hasn't seen those digits before. Let's see if we can run this 5 more times. Notice that we are starting here sort of where we left off at 97%. Now we're up to 98%. This is actually epoch number 8 and number 9. And the final epoch is 98.59. The test data at 97.77. We could continue running it until we have a 99% or greater identification accuracy. So in half a minute, you have seen an entire model being trained and tested on 60,000 training examples and tested on 10,000 examples. This is TensorFlow.